You all are.
So welcome everyone to our first live Science Demystified with Dr. Joe Schwartz. We are back. Thank you for coming in person today. This one is also being recorded and will be available on our YouTube and podcast. So without further ado, please give a big round of applause for Dr. Joe.
Well, welcome to the experiment. We'll see how this works. Anyway, this is the first time after, what is it, two and a half years that we're doing this thing live. But those of you at home can still, of course, enjoy. Well, let me tell you a little bit about how this particular presentation came about. I think maybe we can have a little bit more light. And we don't need, yeah. You know, we have really excellent students at McGill. We really do get the cream of the crop. But it never ceases to amaze me how good they are at learning whatever we teach them now, and how little they know about history, whether it's about literature, whether it's about sociology, whether it's about science. They live in the present. You can have the best possible students and you ask them, when was the French Revolution? And you'll get answers from the 2nd to the 18th century. Of course, my main interest in science. So that's what we're going to talk about. And what I want to do here is kind of draw a timeline for you. Because I know that most people just have no idea when things happened. And I think it's very important to know that. Because, you know, the old adage, if you don't know where you've been, you won't know where you're going. Now, as soon as we mention the word discovery, I think people think of Archimedes, right? And how he was immersed in a bathtub and all of a sudden he yelled out Eureka before running naked through the streets, which was not so unusual in ancient Greece. Eureka, of course, means I have discovered it. And what he had discovered was that when you immerse something in water, the amount of water that is displaced is equal to the volume that is immersed. It is unlikely that this ever happened. There are no real eureka moments in science. I know that there are many allegations that there are. People talk about Newton, of course, and how he formulated the laws of gravity after seeing an apple fall. Not likely to be exactly like that. I mean, he may have been stimulated by the falling apple, but he had already been thinking about these things. And in fact, as he himself said, the reason that he had so many good ideas was because he had stood on the shoulders of giants. And it's very important to remember that although we speak of discoveries in science, there are very, very few aha moments. It is all a sequence of small steps. That's how science works. It doesn't work by giant leaps. Of course, sometimes we talk about that. Neil Armstrong, of course, one small step for man, one giant leap for mankind. Well, not exactly. Because, of course, there were thousands and thousands of people who were involved in that project. And it was incremental until the moon landing finally materialized. So science marches on, but not by leaps and bounds. And I think as we go through this whole business of discoveries, you have to keep in mind that every discovery we talk about has a prelude to it. It was based on other discoveries having been made before, maybe not major ones, until it accumulates, to see the discovery that has become popularized. But where do we start? Obviously with the Big Bang, because that's where everything started. And that took place about 13.8 billion years ago. Now, I don't know, I wasn't there, don't know how that happened, but the interesting question about that, what happened before? What was there before the Big Bang? Obviously, no one knows the answer to that. But according to scientists who look into this business, the Earth formed about 4.5 billion years ago. That's a long time ago. But it took many, many years until humans first appeared. That's estimated to be about 2 million years ago. That's where our story of discovery starts. What was the very first discovery? Anyone have any idea? Before fire. Before fire, it was stone tools. And there are many of these that have been found, and they go back about 1.8 million years. And that's pretty accurate because these can be scientifically dated. And then came fire. I mean, fire, of course, was an absolutely immense discovery because it meant that food could be cooked. It meant that they could keep warm. Huge, huge discovery. So that was about 200,000 years ago. Then about 40,000 years ago, primitive boats were made. First mode of transportation was the boat. And hunting about 18,000 years ago with bows and arrows. Now, although fire was discovered a long time ago, how to start a fire, that was a challenge. I mean, rubbing sticks together was probably the first, or just seeing fire having been started by lightning and keeping that going. But it was about 12,000 years ago that the flintstone was used to make a fire. So that is not all that long ago. This was soon followed by the beginnings of agriculture, so that there were things not only to hunt, but also to gather. And then about 7,000 years ago, bricks. So the construction business got underway. Amazingly, by about 6,000 years ago, glass made an appearance on the scene. That's a 6,000-year-old piece of glass. But you'd like to have that one on your shelf. And then came an amazing invention about 5,500 years ago, and that was the wheel. And that changed everything. Transportation was easier, construction was easier. Now, interestingly enough, that came before writing. Writing only goes back about 4,000 years to Mesopotamia. And then a big breakthrough in farming was the invention of the plow. Now notice that there are thousands of years in between all of these discoveries. So it took a long time for these to be formulated. Now the Chinese, of course, were extremely inventive, and they were into paper making about 2,000 years ago. But they hand wrote on that paper because printing was only introduced around the 8th century. Now notice we've skipped to the 8th century because not much happened actually between AD year 1 and the 8th century. But then things began to happen. One of the most interesting discoveries, again, by the Chinese, when you mix together sulfur, charcoal, and saltpeter, you get gunpowder. That changed the world. How was this discovered? The Chinese were actually into alchemy, and they were interested in finding some magical substance to extend life. And they were trying all kinds of things, including sulfur and saltpeter, because these are readily available materials. And out of that grew gunpowder, an accidental discovery. But they quickly put it to use with the so-called fire arrows. And very often, when new discovery is made, first idea is to somehow use it to harm others. And that's what happened with gunpowder. So by the 9th century, the Chinese were using gunpowder firing rockets. And there was something else that the Chinese introduced around that time in the 11th century, the compass. This was the original compass, a piece of metal, kind of looks like a spoon, and it would tilt towards magnetic north. Quite amazing when you think about it that this was in the 11th century. Well, gunpowder finally made it to Europe by the 14th century. And the European legend is that it was actually introduced by Bertolt Schwarz. This likely is not true. It probably came by means of China. But the European legend is, not to give credit to China, that it was introduced in Europe. And there are even statues of Bertolt in Europe, even though he probably never existed. By the 14th century, they were making cannons. I mean, of course, rather primitive ones, but they very quickly evolved. And by the 15th century, they were able to lob solid metal balls for quite some distance. Now, it's interesting at this point, just to skip forward a bit, to show you how we have evolved and the kind of weaponry that has been developed in modern times. The largest cannon ever made was the Schwerer Gustav railway gun. This was developed by the Germans in the Second World War. This was a monstrous thing, so heavy that it could only be taken on railways. You know who this is? That's Hitler, watching the first firing of this. It was designed to pummel the Maginot Line before the Germans would invade France. This was an amazing weapon. The shells that it would lob, here they are with some American soldiers who captured it. Each shell weighed about 7 tons, and it would be fired a distance of about 47 kilometers. Just think about that. Think of what is 47 kilometers from here. This was able to fire a 7-ton shell that distance. All right, let's get back to the progress of our discoveries. In the 14th century, glasses were introduced. Now, this was very opportune because at that time, Gutenberg introduced the printing press, one of the major discoveries in history, because the first time information could be spread around. So glasses came in handy because people now had things to read. Copernicus. Copernicus, of course, has been made famous because of his theory that the sun was the center of our little universe and not everything went around the earth. Interesting theory at that time, although he was not able to prove this, but he had made some observations about the sky and where planets were. This was all by his naked eye. And he came to the conclusion that the earth was not the center of the universe. And as you can imagine, that upset a lot of religious authorities. Well, the fact is that we learned about the sun being the center of our solar system, thanks to the invention of the telescope made by Hans Lippershey, and that was in the 16th century. That was a really primitive device. It just had a couple of lenses in it. He got the idea from spectacles. He didn't do much with it, but Galileo did. And Galileo, again in the 16th century, was able to focus the telescope out on the night sky, and he observed the moons of Jupiter, he observed the phases of Venus, and he was able to demonstrate that those observations only made sense if the sun was at the center and everything revolved around the sun. As you know, he was also considered to be a heretic, and he was in fact imprisoned in his own home because he believed that The Earth was not the center of the universe. Now, things begin to pick up speed scientifically. In 1669, German alchemist Henning Brandt made an interesting discovery. Now, the alchemists, as you know, were interested in finding the philosopher's stone, which was supposed to be the magical substance that would give them immortality. Obviously, it doesn't exist, but they tried all kinds of things to increase their longevity. And Henning Brandt believed that the secret would be found in urine. Why? Because they knew that gold was essentially immortal. Gold is a metal that doesn't rust, nothing happens to it, it keeps forever. And he thought that humans are born with a certain amount of gold in their body, but they slowly pee their life away. Every time, a little bit of gold comes out, and therefore they are losing their potential for longevity. He wanted to find the secret. So he took a bowl of urine and he began to boil it down to see what would be left. The sun went down, it became dark, and all of a sudden, that flask began to glow. He thought for sure he had found the secret of life. He hadn't. He discovered phosphorus. Phosphates in urine can be reduced to phosphorus to elemental phosphorus with a lot of heat. And this was a major discovery because phosphorus could now be used to make matches. And this, of course, made the creation of fire much easier. Just a little bit later, Anthony von Leeuwenhoek, another major discovery. This was the microscope. So quite the opposite of the telescope. But when you get a mental picture of the microscope, the first microscope did not look like what you think it looked like. This was the first microscope. And it only magnified about 3 or 4 times. He got a little bit better at it after, up to about 10-fold magnification. But Leeuwenhoek was the first one to record and draw what he saw through the microscope. He called them little animalcules. They were bacteria. This was the first time that anyone had ever recorded bacteria. Of course, he didn't know what they were. Then along came Edward Jenner, a monumental figure in history, because he was the one who noted that milkmaids who suffered from a condition called cowpox, they got little pustules on their hands, never got smallpox. He had the idea, therefore, of taking an extract of those pustules and inoculating people with it, the first ever vaccination. The word vaccine comes from cow, the Latin vacca for cow, because of the cowpox connection. And he inoculated a boy, and then after he had inoculated him, he exposed them to smallpox from a sick person, and the boy did not get sick. And thus vaccination was underway. Not much later, Joseph Priestley, regarded one of the greatest scientists of all time, heated a naturally occurring mineral, mercuric oxide, cinnabar, as it was called, and found that it gave off a gas. Now, he did not interpret this properly. We know, of course, what happened here was that he evolved oxygen. He didn't know this. He misinterpreted the experiment because in those days they believed that when a substance burned, it actually released something called phlogiston. This was, of course, a misconception, but nevertheless, he was the first one to actually collect the gas by heating up a solid, and this was then explained by Antoine Lavoisier, who was widely regarded as the father of chemistry. This famous painting by Jean-Louis David hangs in the Metropolitan Museum in New York. It's a fantastic painting that shows Lavoisier with his wife. And Lavoisier was absolutely a brilliant scientist. Here he is shown demonstrating how you can take the mercury oxide, heat it, and collect the gas. And he showed that that gas supported combustion. And not only that, he also used the same equipment to demonstrate that humans were also essentially combustion machines, that we inhale oxygen and exhale carbon dioxide. He met a rather unfortunate end because Lavoisier had a side profession. He was a tax collector. This was not good during the French Revolution. And Lavoisier, one of the greatest minds ever, was guillotined. A head that was never replaced. He was absolutely brilliant. Now, jumping across the English Channel to England, James Watt introduced a steam engine. This was a huge breakthrough because before this, the only way that anything could be propelled was by manpower or by animal power. But he invented the steam engine. And the story, probably apocryphal, is that he was boiling some water in a kettle in the kitchen, and he saw the top bounce up and down as steam was coming out. And this is how he got the idea of steam being able to generate energy. Probably apocryphal, but it's a good story anyway. So he invented the steam engine, but of course the question was, to what use could it be put? And Robert Fulton in the US found a use for it. And this was the first steamboat, the first mechanically propelled boat. And obviously this meant great transportation possibilities along rivers, much, much more efficient than sails or oars. 1800, the year 1800 was a big year in science because Alessandro Volta in Italy invented the battery. Layers of different metals just separated by moistened paper with a little bit of salt as electrolyte, connected to a wire, generated a current. And here he is demonstrating it to Napoleon, who was very interested in science. And this, of course, was the beginnings of electricity. The steam power, which Fulton had used for a ship, was then used by George Stephenson for a locomotive. This was introduced in 1825 in England, and that is the first locomotive ever made. Now, just around the same time, I think you will be very surprised by the next invention, because this, 1821, basically was the first ever computer. It was a very clever device. It could carry out simple calculations. 1821 is when we're talking about. Very, very clever. During the same period, Michael Faraday, arguably the greatest scientist who ever lived, based on the number of achievements, the number of discoveries. His name, though, is most associated with electricity because he invented not only the electric generator, but also the electric motor. That, of course, changed the world. Everything today functions on electric motors. There are something like 100 electric motors in your car. Your garage door, of course, works with an electric motor. Your fridge, your stove, everything has an electric motor in it. All of that can be traced back to Michael Faraday. Photography began in 1827 with Nicéphore Niepce in France. This is the first photograph in world history, first photograph ever taken. It is of a scene looking out his window. This was done by using salts of silver, which when exposed to light turned dark. It wasn't very, very good, at that time, but photography evolved very, very quickly, thanks to Louis Daguerre, who really essentially perfected the process. That is Louis Daguerre in a photograph taken of himself. This was what is known as a daguerreotype. And look how detailed that is. And in 1846, we had the first daguerreotype of Abraham Lincoln. That's what he really looked like. Notice no beard, no stovetop hat, right? So photography evolved very, very quickly. Then, same period in Germany, Friedrich Wöhler, reportedly a pretty ugly man, but he was huge in science because of one single experiment, which you may not think is very relevant. In 1828, he took ammonium cyanate, which is a mineral. He heated it, and he discovered it converted to urea. This changed thought at that time dramatically, because it was believed that materials in the world divided into two categories: natural substances, which could never be created by man, and substances that could be made by man, stone tools, etc. He showed that he could take a stone and convert it into urea, which was found in human urine, an organic substance, as they called it at that time. And this changed the world, because no longer did they think that substances that nature made could not ever be made by humans. So this really was the beginning of synthetic chemistry. Then before long, communication started to evolve. Cook and Wheatstone invented the telegraph. A lot of people think that that was invented by who? Morse. Samuel Morse did not invent the telegraph. What he did was build upon the work of Wheatstone and made it really functional. He did develop the Morse code, that's true, and he also developed long-range telegraph systems, the wiring and all of that. But here's another interesting example where one builds upon the work done by others. It is never one single discovery, although that is often the way that it is portrayed. In 1846, we had one of the most monumental discoveries ever, the discovery of anesthesia. Before this time, if you had to have surgery, and they do surgery, they knew, for example, that if someone was injured in battle and they had gangrene oozing out of their leg, the only way to save them was to amputate the leg. But imagine what that is like without any anesthetic. So what did they do? They either plied people with opium or alcohol, but no matter how drunk you are, you tend to notice if someone is sawing your leg off. Or sometimes they would just knock them out with a knock on the head. Sometimes the anesthetic proves to be more deadly than the disease. But in 1846, as depicted in this classic painting, William Morton introduced the inhalation of ether as an anesthetic. William Morton was a dentist. Dentists, of course, were very interested in pain relief. And he introduced the idea of ether inhalation. He had learned about that from a chemistry professor, Charles Jackson at Harvard, because Morton had approached him because he was interested in finding out if there was anything that could be inhaled that could put people to sleep. And he figured, who better than a chemistry professor to put people to sleep? So he asked Jackson, and Jackson said that he had noticed that his students would sometimes go fuzzy when they were inhaling ether. This is what Morton built upon. He went to Massachusetts General and approached the surgeon, the chief surgeon, John Collins Warren, and told him that he has something that would be able to put people to sleep and that they could recover after. Warren was very, very suspicious of this because others had tried anesthesia, none of it worked. But this time it did. And he looked around because only men were doctors at that time who were at that original surgery. And he said, gentlemen, this time this is no humbug. And ether anesthesia was born. That was in 1846, the same year that nitroglycerin was discovered. Quite a different kind of a discovery. This was made by Ascanio Sobrero, an Italian, who found that if you took glycerin, which was made from animal fat, and you reacted it with nitric and sulfuric acid, you got a material which was extremely explosive. In fact, it was so explosive that if you just dropped it, it would explode. And you don't need very much nitroglycerin to cause tremendous damage. This is why, you know, when on airplanes, they tell you that you can only carry 125 milliliters or whatever of a liquid. Well, I tell you how stupid that is. 50 milliliters of nitroglycerin could bring down an airplane. So that's total nonsense. You know, this whole liquid thing depends on what that liquid is. Now we come to some Canadian discoveries. Alexander Graham Bell actually was not born in Canada, he was born in Scotland, but Canada has kind of adopted him and claimed that, you know, he was the inventor of the telephone. Well, here too, the story is much, much more complicated than it first seems. Indeed, in 1875, he did introduce the telephone, and the first message, as you may have known, was to his assistant who was in another room. Anyone know what was the first message? Mr. Watson, come here. Yeah, that was the first ever message over the telephone. But the fact is that very similar appliances already had been invented. And Bell just built upon that. In fact, there's a big controversy because in Italy, Antonio Meucci is recognized as the inventor of the telephone. And there were lawsuits back and forth about this. To this day, it's somewhat controversial. But again, you know, it's not one person who makes a discovery. It is built upon what went on before. 1856, one of my favorite discoveries, William Henry Perkin, a young chemistry student, was trying to make quinine in the laboratory. He became frustrated because nothing was working. He threw his chemicals into the sink, and all of a sudden the sink turned into a brilliant color. That color, of course, came to be called mauve. And that was the first ever synthetic dye. Before this, natural dyes had to be extracted from plants and animal matter. But this was a new color. No one had ever before seen this beautiful, brilliant color. It took the world by storm. Queen Victoria was a big fan. She wore purple until, anyone know, until when? When she changed? Until she lost her husband. When Prince Albert died, from that moment on, she never wore anything except black. She mourned him for the rest of her life. But before that, she was very fond of mauve. Now, of course, if mauve could be made synthetically, other colors too. So the chemical industry jumped on this, and pretty soon we had all kinds of dyes. And interesting enough, this also is looked at as the beginning of the pharmaceutical industry. Because if you could make novel substances like dyes, maybe you could make novel drugs as well. And of course, that eventually turned out to be the case that we'll see in a moment. And then in 1859, Charles Darwin published his classic work on the origin of the species. He, of course, was aboard the Beagle as it traveled around South America, and he made the classic observations of the finches with the twisted beaks and came to the conclusion of how things evolved. And essentially, he really was correct about just about everything. So he was the founder of, you know, people say the theory of evolution. That's wrong. Evolution is not a theory, evolution is fact. So he was the first one to really document evolution. That's the way to say it. Now, at the same time, back in England, Alexander Parkes made the first ever plastic. Now, this was made by modifying cellulose. Cellulose is natural material. This is what cotton is made of. This is what we have, wood. It's a major component of wood. He found that if you took cellulose and reacted with nitric and sulfuric acid, you change it into a novel material. And this became the world's first plastic. It eventually came to be called celluloid. Now look, we're looking in the middle 1800s. Here's the first plastic. Look at the beautiful things that were made out of this in the middle 1800s. At the same time, dynamite was introduced. Dynamite, of course, was the brainchild of Alfred Nobel, and it was based upon Assanio Sobrero's discovery of nitroglycerin. Now, the trouble with nitroglycerin was that it was very, very sensitive to impact, as I told you. So it was difficult to transport. In fact, there's a fantastic movie about that. About transporting nitroglycerin through the Andes Mountains. Anyone know what that movie is? There were actually two versions, original and there was a remake, called The Wages of Fear. And it's all about the transportation of nitroglycerin. It's a great movie. Anyway, so Alfred Nobel wanted to harness the energy of nitroglycerin. And he found that when the liquid was mixed with clay, it was no longer sensitive to impact. It had to be lit. And this was the beginning of dynamite. But Nobel also recognized that this could be used to the detriment of mankind. And that's why he left his fortune, which was immense. He made tremendous money of dynamite. He left his fortune to be given out in the form of the Nobel Prizes. The Nobel Prizes, which have been given out since 1901, the prize money is still coming from the interest of Nobel's original fortune. And these days, that prize money is about $1 million for every winner a year. So Nobel, of course, wanted to make sure that science would progress in the best possible way. The most prolific inventor in the history of the world was Thomas Edison. He, of course, is regarded as the inventor of the light bulb, which he did not do. We'll get to that in a moment. He has over 1,000 patents in the US and over 1,700 global patents, all to his own name. He never had anyone else's name on the patents, even though he had all kinds of people working with him. This is a record that will never, ever be broken. No one ever will have that many patents. But the one that really was totally his discovery, and this comes close to an aha moment, because it was not based on any previous work. This was totally his idea, and that, of course, was the phonograph. And just imagine how remarkable that was, to hear sound coming out of a machine. I mean, no one had ever seen or heard anything like that before. So he was able to record sound on these little cylinders by speaking into a primitive microphone that was attached to a needle that would etch a groove into a cylinder. Now, interestingly enough, Edison also was big at advertising, and the phonograph originally was advertised as his final achievement, which of course was not true. He had many, many other patents after this. Now, of course, as soon as you mention Edison, people's minds, of course, right away switched to the light bulb. What Edison did was to make the light bulb practical. And he also introduced the first large-scale electrical generating system. But he did not invent the light bulb. That was done by Joseph Swan in England. However, he did not have a filament that could last a long time. So his light bulb worked, but only for short periods of time. Edison was the one who worked and worked, tried, as the story goes, over 1,000 different substances to see if he could find the right filament. So he was a workaholic. He would usually sleep in the lab, not wash. His telegraph name, coined by his workers, was Dung Heap, because apparently he had a certain fragrance because he didn't wash. He slept in the lab all the time. But he just did a lot of elbow work. He just brutalized science, until it conformed to his wishes. And he also always said that if he couldn't make money off of something, he was not interested in inventing it. By all accounts, he was not a nice man, but he was indeed brilliant. The car came about in 1886. That's the first car. First car. We've had some serious developments since that time, right? So that was in 1886, invented by Benz. Soon after that, Wilhelm Röntgen, an absolutely huge discovery that, of course, plays a role in our almost daily lives. When he found that there was a type of ray coming out of a cathode tube that could make a type of screen glow, and of course, not where you blocked the rays. And this was the invention of the X-ray. He called it X because he didn't know how it came about. X, of course, in mathematics is term for unknown. The very first X-ray that was ever taken was taken of Röntgen's wife's hand. This is a remarkable achievement, and here it is. And you can see her ring. The very first X-ray in the history of the world. And the very first X-ray tube that gave off the X-rays is this one here. It's in the Smithsonian Museum in Washington. The first Nobel Prize in physics was awarded in 1901, and that went to Röntgen, because this was such a monumental discovery. And he was recognized in 1901. This was the very first time that the Nobel Prizes were given. And here is the citation for Röntgen for his discovery of X-rays. In France, Henri Becquerel was also active in a very similar area. He found that certain salts of uranium also gave off mysterious rays, different kind. This was the beginning of radioactivity. The term radioactivity was actually introduced by Marie Curie, who did a lot of work on radioactivity, also discovered radium and discovered polonium. She became the first woman ever to win a Nobel Prize. She, in fact, won 2 Nobel Prizes. She won 1 Nobel Prize together with her husband, Pierre, for the discovery of radioactivity. And then she won another one in chemistry later on by herself for the discovery of radium and polonium. Still widely regarded as probably the greatest female scientist ever. Unfortunately, her discovery also killed her, because radium is very, very dangerous. Of course, it emits radioactivity, and they didn't know in those days how dangerous it was. She always carried around a little vial of radium. She loved to show people how it glowed, and she eventually suffered from leukemia. Marconi, 1897, the first ever radio transmission. The equipment was pretty complicated. That's the way it looked. That was the first radio transmission. So this is barely over 100 years ago. And it was around the same time that the pharmaceutical industry got going with the introduction of aspirin by Felix Hoffmann at the Merck company in Germany. Now this again was a spin-off from William Henry Perkins' work, because Perkins had showed that you could make substances in the laboratory. And Hoffman took salicylic acid, which could be isolated from plants, reacted it with acetic acid, essentially vinegar, and made acetyl salicylic acid. It became the best-selling drug. Still, it is the most widely sold drug in the world. Now we come to McGill's pride, and that was Ernest Rutherford. Rutherford was a New Zealander, but he did a lot of his work here at McGill. And the Nobel Prize that he got was, in fact, for work carried out at McGill. He had discovered, well, not discovered, Curies had already discovered radioactivity, but they didn't know what it was. But Rutherford was able to explain that radioactivity was the result of atoms breaking down into smaller pieces. And this was a monumental finding because it would eventually lead to nuclear fission, and we'll see all of the consequences of that. Now, as Rutherford was working here at McGill in the lab, at Kitty Hawk in North Carolina, Wilbur and Orville Wright were testing the first airplane. And it didn't fly very far. It only flew about 100 yards on the first flight. It was longer on the second flight, etc. But again, there was a lot of preamble to this, because before they had motorized flight, the brothers were aware of all of the trials done with gliders. People had been experimenting with gliders, so they knew how to control these. That was really the precursor of the airplane. So it's not that it just, they got the spontaneous idea. There are all kinds of people who had tried to come up with flying devices. Then in 1905, Einstein, with his theory of relativity, which is very difficult to explain, but physicists, of course, worship this because it means that energy and mass are interconvertible. And the best example of that is the atom bomb, because there you convert a small amount of mass into a tremendous amount of energy. And Einstein, of course, knew about this. And as you probably know, he wrote a letter to Roosevelt because he was worried that the Germans already were developing the atom bomb. And he wrote a letter to Roosevelt that the US better get on this. And they did. And that was really the launch of the Manhattan Project. Now, in those days, the Germans were at the forefront of science. The best scientists in the world were in Germany. That's why, it is so difficult to understand how that nation, with a history of philosophers, of literary giants and scientists in the 1930s, went down the sewer the way that they did. This was not some primitive country. This was a country with the brightest minds at the time in the world. And yet a single madman with his oratory was able to convince them to take the path that they took. Fritz Haber was a Jew in Germany, and he was the first one in 1905 to synthesize ammonia. Now, why should this matter? One of the most significant discoveries in history, because nitrogen and oxygen, of course, are available in the air, but it was always difficult to know what to do with those gases. Nitrogen was very important. It was known that nitrogen was needed by plants to grow, but plants can't use the nitrogen from the air. They can only use compounds of nitrogen. And Haber found a way to make nitrogen react with hydrogen to make ammonia, which could be made into ammonium nitrate, the world's first fertilizer. This was hugely important. Without that, there would have been massive starvation in the world as populations increased. This was the beginning of what we call the Green Revolution, especially in Asia, where millions of people would have starved if it were not for the introduction of ammonium nitrate fertilizer. Haber, unfortunately, had another side. He was a valiant German, and during the First World War, he worked on developing poison gases. And therefore, there was a lot of controversy when he got the Nobel Prize for fertilizer because of the work he had done on poison gases. In 1906, Leo Baekeland, a Belgian chemist who emigrated to the US, introduced the first ever true plastic made from simple materials. He didn't just alter an existing material like Parkes did with cellulose. He was able to take small molecules, phenol and formaldehyde, and react them and make material that he called, in all modesty, Bakelite. This was a wonder material. The first telephones were made out of these. Some of you will remember that, right? Nice, heavy phones. When you threw that at someone, they felt it. Not like these little flimsy cell phones that you throw at someone and bounces off of them. The first television sets were made of Bakelite. And interestingly enough, today, Bakelite has become a collector's item. Some of the early pieces of jewelry, early radios are highly, highly collectible. Henry Ford introduced the assembly line. This made cars available to the general population. The Model T, of course, became famous, but Ford also was the first one to allow proper vacations for his workers. He was very good for his workers, but he was a horrible man. Ford was an absolutely flagrant anti-Semite. He wrote numerous articles on how Jews were controlling the world. But of course, he contributed a great deal to the automobile industry. Television first became available to, well, not to people yet, but as an invention. That was in the 1920s, the Baird television set. That was the screen. But I think most people are surprised to find out that 1928 was pretty early, that television was already available at that time. In Canada, huge contribution by Banting and Best with the introduction of insulin, which changed the life of diabetics. Before that time, diabetes was a death sentence. But with insulin, diabetics could lead a long life. The first person ever to be injected with insulin was young Leonard Thompson. And this, of course, was a huge story, made headlines everywhere. And Banting got the Nobel Prize for this in 1923, although Best did not. This was a huge controversy. The Nobel Prize went to Banting and MacLeod. MacLeod was the one who was in charge of all the laboratories at U of T at that time. He actually had nothing to do, or virtually nothing to do with insulin. And when Banting got the Nobel Prize, he was very annoyed that Best was not part of it. He split the prize money with Best. In the United States, 1926, the first ever liquid-fueled rocket. Not very impressive, as you can see. And this was launched by Robert Goddard in his Aunt Emma's cabbage patch. It only went up a couple of 100 feet, but this really introduced the idea of rocket flight with liquid-fueled rockets. The Germans eventually capitalized on this, as I'll show you in a moment. In England in 1928, the most famous mold in the history of the world flew into a lab and landed in a Petri dish. That Petri dish, of course, was the work or belonged to Alexander Fleming. Fleming was trying to work on antibacterial substances, and he had left a Petri dish with bacteria over the weekend in the lab. The window was open, mold flew in, it colonized the Petri dish. When Fleming came back, he noticed that the bacteria had been killed around the mold. This was, of course, was the beginning of penicillin. He was never able to bring this to fruition. He had just made the observation. But eventually, it was a moldy cantaloupe in Peoria, Illinois, that allowed the large-scale manufacture of penicillin, because that particular cantaloupe produced a mold that was extremely efficient at making penicillin. Now that efficiency was capitalized on by Florey and Chain, who together with Fleming eventually got the 1945 Nobel Prize. Of course, Fleming had never worked with them, but he was recognized because without his accidental discovery, none of that would have happened. And during the Second World War, penicillin was widely available to the Allies, which helped win the war. Germans were dying from all kinds of infections, but the Allies had penicillin. Just prior to the Second World War, maybe the most famous plastic of all, nylon, was introduced. This was the work of Wallace Carruthers at the DuPont laboratory. And boy, did this ever make a splash. On so-called Nylon Day, when it was nylon stockings were first sold at Macy's in New York, ladies stood in line to get their hands on these wonderful new stockings made from petroleum, because that's where the raw material came from. And that really captured their imagination. But also helped during the Second World War, because when the US was cut off from their silk supplies by the Japanese, they used nylon in the parachutes, which previously had to be made out of silk. Alan Turing in 1936 introduced the Turing machine, which basically was designed to decode German secret messages, but it actually was a computer. And Turing, unfortunately, did not get all the recognition that he deserves because he was gay. And in those days, that was just not acceptable. In fact, in Britain at that time, people were jailed for being gay. Now, as I said, a lot of advances were being made in Germany at that time, and Otto Hahn and Lise Meitner discovered how an atom of uranium could be split by bombarding it with neutrons. This was an extension of the work of Rutherford. And Otto Hahn was widely recognized for this discovery. Lise Meitner was kind of swept aside because she was Jewish, and also because she was a female. And she never got the recognition that she deserved. The war also hastened the introduction of radar, which helped change the outcome of the war because the Allies had radar and the Germans didn't. So in England, they knew when the German bombers were coming and they could fight back. Then in 1942, Enrico Fermi, capitalizing on the work of Otto Hahn and Lise Meitner, scaled it all up to show how uranium could be split and produce a lot of energy. And at so-called Skag Field in a squash court at the University of Chicago, the first nuclear pile was built. This was all secret. This was all part of the Manhattan Project. And splitting the atom, of course, releases tremendous amounts of energy. The Germans, during the Second World War, designed rockets, the famous V2, to be launched against England. And this really was the beginning of the space race. Now, Robert Goddard had shown that rockets could be designed, but the Germans brought this to fruition. Those rockets could travel 200 miles. The same time brought another invention, and this was the microwave oven, an accidental invention. This was noted by, as you can see, Percy LeBaron Spencer, who had a chocolate bar in his pocket, and he was working with a radar installation. Radar releases microwaves. The chocolate bar melted, and the microwave oven was born. Of course, at first it was only commercial. It took a long time until it found its way into people's kitchens. And then, of course, came the monumental event in 1945, when the results of the Manhattan Project were put into practice, and the atom bomb was dropped on Hiroshima. Of course, there's a lot of arguments about whether this was necessary or not, because Germany had already surrendered, Japan probably would have surrendered, but the US wanted to demonstrate to the Soviets that they had the nuclear bomb. And the very first atomic bomb, before being dropped on Hiroshima to test it, was detonated in the desert in the US. And that's the picture of the first ever experimental detonation. Another fantastic discovery that played a big role in our life, 1947, when at the Bell Laboratories, Bardeen, Shockley, and Brattain developed the first transistor. Because every electronic device, from your cell phone, your computers, your television sets, everything requires transistors, which are basically tiny little on-off switches that control the flow of electricity. Everything, every electronic device needs a transistor. So that goes back to 1947. In 1953, Crick and Watson discovered the structure of DNA, which of course was another huge step forward. And they've got the Nobel Prize in 1962 for this. Now, nuclear energy, of course, can be used to kill, but it can also be used for peacetime energy generation. That was introduced by the Soviets in 1954. They actually built the first ever generator that relied on nuclear energy. In 1956, a discovery, I think that you'd be surprised, because this was a discovery that totally changed the world. This was the introduction of the shipping container, which allowed transportation of goods around the world. This was the first ship ever to use a container. Before this, longshoremen had to fill sacks and manually, pile them onto ships. Today, the reason that we have pretty cheap commodities, or at least we used to have cheap commodities, is because transportation like this is cheap. There are huge, huge ships. This is the largest one, the Ever Race, 400 meters long. Think about that. That's 4 football fields long. It carries 23,992 shipping containers. This is why we have everything. This is why you go to the dollar store, every item that you see there has come here by ship. Changed the world. Of course, so did the discovery by this Albert Sabin of the oral polio vaccine in 1958 and the Salk polio vaccine. These were monumental. Then in 1957, this headline appeared in Pravda, the Soviet newspaper. You probably can't read that, but here's the corresponding headline in the Washington Post, describing the launch of Sputnik, this tiny little ball that circled the globe. It had no practical importance. The only thing it did was it emitted a beep, irritatingly once an hour. That beep was heard above Washington. Why was it so irritating? Because what this demonstrated was that the Russians had a rocket capable of putting a satellite into orbit around the Earth, which meant that they had a rocket capable of launching a nuclear weapon at the US. That was the huge breakthrough here. And then, of course, the Soviets followed this by putting a man into space, Yuri Gagarin, in their Vostok 1 rocket. The Americans could not, at that time, compete. The first American launch of Alan Shepard was just a straight up and down mission. It only lasted 15 minutes. They didn't have the power in their Redstone rocket to put a man into orbit. But there in that capsule is Alan Shepard lying on his back in a pool of urine, because this was supposed to be a 15-minute launch. And of course, no one thought about his need to go to the bathroom. But it turned out that once he was in the capsule on the ground, there was a problem, and there was a hold that kept getting longer and longer and longer. And he contacted through an emergency channel the control tower, and he said that there's going to be more than one kind of launch here. And they didn't know what to do. And eventually they made the decision to allow him to urinate into his spacesuit. And in that capsule, at that very moment, is Alan Shepard in a pool of urine. Then in 1969, of course, the most famous launch ever, which was the Saturn V. And that is what took men to the moon, and of course allowed Armstrong to step on the moon. And it really happened, unlike the conspiracy theorists who say that it was all filmed on a back lot. 1969, the first ever landing on the moon, arguably mankind's greatest ever technical achievement. The computer was introduced by Stephen Jobs and Wozniak in 1976. That is the Apple computer. And it was at the same time that the first ever landing on Mars by Viking, the same year. Soon after was the launch of the space shuttle, which allowed up to 7 people to travel into orbit around the Earth. And that at the same time, the first ever cell phone was introduced. It was a little bit cumbersome to carry around. And then something that we use every day in 1983 was the birth of the internet, when they figured out how computers could be linked to each other and transmit information around the world. Completely changed our life. The Hubble telescope, launched in 1990, allowed us to peer into outer space. In inner space, 1994, genetically modified foods were introduced. The first one was the tomato, which was supposed to be better because it was allowed to stay on the vine longer and not over ripen, and then you could pick it and it would taste good. Never worked. But other aspects of genetic modification did. Corn can be protected against insects. It is resistant to some weed killers, has increased yields tremendously. In 1998, the Space Station, International Space Station, was put into orbit. And in 2007, the first iPhone was introduced. And of course, we've had many developments since that time. And Steve Jobs followed this with the iPad. More recently, we've witnessed the James Webb Telescope, which is going to give us a glimpse into that Big Bang, which is so mysterious. And this can essentially look back in time, because the light that it sees, of course, is light that has been emitted millions of years ago. We'll see where this leads. Again, inside of the laboratory, researchers now are able to edit genes, take out fragments of genes that may cause disease, replace them. This is the so-called CRISPR technology, for which the Nobel Prize was given to 2 women for their development. So that kind of brings us up to date. And of course, this has been a very quick journey to discovery, so that you can imagine one can give a whole course, essentially on every single one of those discoveries. But at least this gives you a little bit of a glimpse into the time frame of when things happened. And that's very important to, as I said at the beginning, to know where we came from and where we're going. I'll just mention one more thing. This was live performance, the first one in years, and we're going to repeat this actually next Monday at McGill with our annual Public Science Symposium. And obviously, what else can it be but stress, which we have all been experiencing over the last couple of years. And we have 2 fascinating speakers. Melissa Lam is an expert on what we call forest bathing, on reducing stress by going out into nature. And there are people who believe in this. Who believes in this? You go out for a walk in the forest and you feel better after. You don't have to have a destination to go. It's just being out there, inhaling the air, supposedly relaxes you. She'll talk about that. And John Denninger comes to us from Harvard University and Massachusetts General Hospital, specifically the Benson Henry Institute for Mind-Body Medicine. And he's going to talk about how not all stress is bad. But if you know how to stand up to stress, sometimes it can be put to good use. All right, so that is it. If you have any questions or comments, we can certainly entertain them. Who else but Stanley with the first hand up? Yes.
Nitroglycerin. Is that the same nitroglycerin that people have?
Yes. Nitroglycerin, it's exactly the same nitroglycerin that you take as a medication to dilate blood vessels. Yeah.
So what's the difference? Why is that? Just nitroglycerin?
Oh, the amount in there is milligrams. But there also are nitroglycerin patches that you put on the chest. And there have been cases where people have had a heart attack and they've had the nitroglycerin patch on, and then they come with the paddles to start to try to restart the heart, and the patch explodes. There have been cases like that. But the amount of nitroglycerin in the pill is minimal. Yeah.
I'm sorry, I'm not the name of the scientist who discovered the
Faraday. Yeah.
So what do we have in our electrical system named after Volta, named after Watt, named after
Oh yeah, sure it is. The Faraday. There are many things that are named after Faraday. Electrical charge is measured in terms of Faradays. The Faraday cage is something that blocks electrical discharge. So no, there are many things that are named after Faraday. Volta, yeah, I mean, he deserves the credit because he was the first one to come up with a battery, which really was the beginning of electricity. But Faraday does get recognition, certainly. Faraday was also a fantastic lecturer. And at the Royal Institution in England, in the early 1800s, they began the Friday night public lectures, which were extremely popular because he was such a great presenter. And of course, in those days, you didn't have TV, and so the live things were the only way that you could be entertained. And the very first street in the British Empire that was made one way was Albemarle Street in London, where the Royal Institution is, because the traffic, the carriage traffic was so intense coming to Faraday's lectures that they had to make the street one way. Yeah. Yeah.
So 7:30.
Yeah, it's 7 o'clock. We changed that. It's 7 o'clock. Yes, we do also have a roundtable event with the speakers at 1:30, and yeah, anyone can come to that as well.
Is that on Zoom too?
It will be on Zoom, not simultaneously, but it will be recorded.
Could I ask Matthew about people getting older? We wrote that, for example, in Montreal newspapers 40 years ago. Would we see a big difference in the obituaries from today? I have two friends that work in the insurance industry that claim that the big difference is in child's life expectancy, not into old age.
This is true. This is true. So life expectancy from 70, once you're 70, the life expectancy from then on has not changed since about, The reason that a lot of the increase in average life is because, of course, we wiped out many childhood infections and childhood diseases. But yeah, so yeah, once you reach the age of 70, your expectancy is the same. Yeah. Yeah, I mean, of course, there's all kinds of things that you can do to try to improve your expectancy, and exercise and eating right.
Dr. tell you, this Jewish fellow who was 90 went to see a doctor. said to his doctor, I want to live another 30 years. Doctor said, that's fine. He said, I have to ask you, Boris, do you drink? He said, no. Do you smoke? He said, no. He said, do you do drugs? He said, no. He said, do you chase women? He said, no. He said, so what's the point?
Right.
It's an old joke.
Yeah, you know, they're
It's an old
the old jokes, you know, there's always new people. So for a new person, the old joke is new.
You know, Dr. Ford, I should take my daughter's doctor. She lives in Australia. She said, Dad, these jokes that you tell are what the dangerous jokes. They're sexist and stop it. The only joke I'm allowed to tell is I could ask a lady, what's your first name? Yes.
Anna.
Annie?
Anna.
Hannah? Hannah, there was an ad in the newspaper, baby doctor saw it. Said lady wanted, and Hannah applied. The boss was a big tough guy. He said, Hannah, I'm looking for a lady who can do the job of 10 men. And you know what Hannah said? She said, I thought this was a full-time job. I'm the only joke I'm allowed to tell her.
All right, now you've also relieved some stress because, as they say, you know, laughter is the best medicine.
Last question.
With the name of Tesla, Carl, you didn't mention Tesla.
Yeah, you're right. Tesla should have been in there. Tesla should have been in there. You know, it's very difficult to know who to put in and who not. Tesla was really the first person to come up with the transmission of electricity wireless. That was a big thing. Tesla was a strange man. You know the story that he fell in love with a pigeon. Yeah. Anyway, yeah. I mean, one day, you can do a whole talk on Tesla. Yeah. I mean, there's a reason that the car is named after him. He does deserve that. Okay. Thank you.
Thank you so much for coming. Our next lecture with Dr. Joe will be on October 3rd, and the topic will be the workings of the brain. If you'd like to rewatch this lecture, you may do so on the cote-saint-luc YouTube channel or on our podcast. Thank you very much for those of you joining in person and those of you joining online.